Welcome, everyone. I'm Dr. Erika Gray, co-founder and chief medical officer of My Toolbox Genomics and Toolbox Genomics. I am coming to you live from Southern California today, a little bit of a change in scene, and I wanted to talk to you all about eye health and the role of DNA and epigenetics with eye health. Please remember that My Toolbox Genomics cannot diagnose, treat, or comment on anyone's particular conditions. This is medical information only. So without further ado, we are going to jump right in and talk about all kinds of really interesting topics. When I was getting ready for this discussion, one of the things that I found fascinating is that study after study shows that people actually fear vision loss more than they fear cancer, stroke, heart disease, and many of these other conditions. And what's fascinating is that so people fear this, and they also feel that they're incredibly well versed in vision health and what they need to be doing to take care of it. But what comes out for a lot of people is that they're actually not as well versed as they think they are. And so my goal in this presentation is to give you some more information so you really understand what you can do, how you can help yourself, and avoid some of these conditions that can be really scary for people, and it can really change their life. I think one of the things that we don't realize with eyesight too is that it's very, very subtle. It happens over time. We all have seen our parents start to wear glasses over time. So I think we all are ready and expecting that to come, but we don't necessarily realize what are some of the conditions that can come up because there's no warning signs, or so it seems, I should say. I'm hoping that this live stream is going to help dispel some of those myths. But for example, like glaucoma doesn't necessarily have any specific warning signs. Age-related macular degeneration usually is happening subtly in the background, but then it just becomes very obvious to your eyes. And so because those symptoms tend to be very sudden or worsen quickly. So I think the thing with the eyes is that most of us, as we get older, start to notice that we can't see as clearly, or maybe we can't see as far. But that's about it. And we don't really dive into all of the different eye conditions, and we don't necessarily associate what's going on in other parts of our life and our health with our eye health as well. The two are very interrelated. So to get us going, Heather asked, what are genes associated with eye health? So Heather, we're going to get into those right now. And Ed wanted to know, what impact do DNA factors have on cataract formation? So I'm just going to touch upon this for a second, and then we're going to get into some more details. So genetics tends to play about 37 to 58% of its role in cataract formation. So remember, genetics simply sets the scene, and then the scene for your stage, and then depending on how you're going to choose to act in your play of life, that is going to be the thing that's going to dictate how it manifests itself. So really, really important. What they found is that for many people, the genetics is going to be the signaling. It's going to be the thing that you have a higher predisposition. You don't take care of yourself, then your chances of developing some of these eye-related conditions like cataracts is much, much higher. So let's talk about some genes here. So the HTRA1 is a serine peptidase that is secreted by the retinal pigment epithelium. So we have talked a lot about the epithelial cells or the epithelium in relation to our arteries, in relation to our heart, but it's also in our eyes as well. And what's really interesting is that stress and inflammation tends to upregulate the production of this particular protein. And when you upregulate this protein, you cause more of this retinal pigment epithelial death. And so when you have death, or anything what we call apoptosis, like a programmed cell death, and we don't have a way to support it or replace it, then this is where we can start that cascade of degradation or change that might be happening in our eye as well. The other thing that I think is really important to note, to highlight again, is that stress and inflammation. So we've talked a lot about those two things. Now, when we are when we feel stressed, yes, of course, that's going to affect our eyes, but we also want to realize that certain things that we do in our life that doesn't necessarily make us feel stress actually stresses our eyes. And we're going to talk about blue light. That's a really, really important one to know on that. Another one is this ephrin type A receptor 2. This is again expressed in epithelial cells in the ocular lens. It's really important that we have all of our signaling, the way our cells stick or repulse or move around together, are really, really well tied in together. This is important in maintaining lens homeostasis. So we've talked about when we homeostasis, the body really likes to keep us at the same position. It doesn't like big fluctuations. Also for lens transparency. And so one of the thoughts is that when you have changes in this particular gene, then you're more predisposed to cataracts because of that cloudiness that can start to come into the lens as well. MYOC is going to play a role with intraocular pressure. So intraocular pressure is very important in the area of glaucoma. We're going to have some visuals and some other things coming up as well. So what ends up happening is that when you are older and you go to get, and you have an eye exam, they will check your intraocular pressure, how much pressure is being put in your eye. And there are different types of glaucoma. There is juvenile onset. There is primary open angle glaucoma. And this is something that eye doctors definitely watch, because as your eye pressure goes up, it's an indication that glaucoma is starting, and it's now starting to take over. And glaucoma gets to be incredibly painful in the eyes. It's like having something constantly pushing on the back of your eyes, because essentially that area behind your eyes has now gotten bigger. And so now it's putting additional pressure on your eyes. Age-related macular degeneration is a loss around the periphery, and you tend to start to have blurry vision. And what they found was that they were actually studying octopuses and how octopuses can detect polarization. So a really good example is if you have a pair of sunglasses that are polarized, there's a real richness and a depth of field that you can see. And if you put those sunglasses on, it's polarized, and when you take it off, the polarization leaves. But we naturally have polarization in our eyes. And we can pick this up because we absorb violet blue light, and it goes into this part of our retina. And so with that, we can actually pick up like some of the peripheral vision. So even though I can't see, even though my hands are here, I can almost go all the way back here and I can still see them in my peripheral vision. But you start to lose that. And so they actually were studying octopuses, and from that information, they were able to, the way octopuses were able to pick up the polarization, that's how they're now utilizing it in picking up macular degeneration for individuals, which is really, really interesting. And macular degeneration is really a big, big problem. It happens to many, many people. It causes severe eyesight. You don't go blind from it, but your ability to see in fine detail, your ability to drive, see faces, smaller print, all of those things happen over time with age-related macular degeneration. And here's the other part of it. A lot of those symptoms that I just read off also are very similar to just vision degradation as we get older as well. So sometimes people don't realize that they're actually going through AMD as well. So when you get your results, there is a whole section on the app around eyesight and also on the epigenetics. So we're going to touch upon that. So this particular section, slight degeneration with age, relates to age-related macular degeneration. And so you can see where you are genetically if you are more inclined to have a faster decline or a normal decline, or maybe even a slower decline as well. Cataracts is another one, and cataract surgery is incredibly, I would say it's much more common. I watched my father go through it, my grandmothers go through it. And the thing that everybody comments about is that when they have their lenses replaced, their clarity is so much more potent and powerful in terms of what they can see. So here's what's very interesting is that for individuals who don't have access to eye care or are not keeping up on eye care, cataracts can be a huge contributor to loss of vision. And what they find is that certain parts of the world as well, where there's a lot of UV exposure, and we're going to talk about that as well, and you're not protecting your eyes. And again, remember, there's physical protection and then there's internal protection. So protection from the inside out. That you really want to utilize in both ways for, we talked about like with your skin, but also for your eyes as well. And the internal role in this is not only nutrients, but caffeine, specifically coffee, seems to play a big role with cataracts. And so what the thought is that because caffeine really helps scavenge those free radicals. There's the polyphenols. And again, you always want to make sure that you're choosing high quality coffee on this one. So try to get organic coffee, single origin. If you're getting a darker roast, there tends to be more acrylamides that are made. And it may be, I hesitate to use the word toxic, but you may not get all of those antioxidant benefits from it as well. So, but please don't start drinking coffee just because of the cataracts, because you're looking to prevent cataracts, because there may be a reason that you didn't drink coffee. One of them being that you might be a slow caffeine metabolizer. And again, that's something you can take a look at on the app to see how you handle caffeine. If you're a slow caffeine metabolizer, it's really important that you have your coffee early in the morning because of coffee's long half-life. And so when you drink, when you're a slow caffeine metabolizer, that half-life is increased. And some people have even said it might even be around for 36 hours. So in that situation, even if you drink 1 cup of coffee in the morning, your body may never be without the caffeine. And so then it may be a stressor on the adrenals. Different topic for a different conversation, but I just want to share that with you, that there is another component to coffee that you always want to be mindful of because of what it does with the adrenal glands. And also that it might help us get around the fact that we're not getting enough sleep when we really need to adequate sleep as well, which is really important for rest and rejuvenation for all parts of our body, including our eyes as well. So again, just to reiterate, the thought around the cataracts and the coffee is it's the polyphenols and the antioxidants that are found in the coffee that can be very helpful. And one of the other additional thoughts is that actually it's the coffee is feeding our gut bugs that are also making some of these great antioxidants and polyphenols as well. So here's just a quick summary. So you can see that in different parts of the world where they drink the least amount of coffee, they tend to have the highest incidence of cataracts. So again, just interesting to note, as a quick visual, there are several papers out there that you can investigate and take a look at, and they review this as well. Another wonderful, wonderful supplement for your cataracts, your cataract nourishment, is vitamin C. So your body really requires quite a bit of vitamin C. It needs enough to be tissue sufficient. So when you take 500 milligrams, it's not necessarily going to get into your brain or into your adrenal glands or into your eyes, into the cataracts. Those are 3 areas where your body concentrates the most amount of vitamin C. So this is one of the reasons that you need to take adequate amounts of vitamin C throughout the day, because it's a water-soluble nutrient. Your body goes through it very, very quickly, and it's quickly absorbed and released as well. The other thing to remember, and we have a blog post on this on the Toolbox Genomics side, that one of the transporters that picks up vitamin C is also the same transporter that picks up sugar. And your body will preferentially pick up sugar over vitamin C. So if you are, if you have a very sugary dessert or meal, and then you go and you take your vitamin C afterwards, you may not be getting as much vitamin C into your cells as you think you are, or as you hope you are. So just FYI on that. So here's what they found. So again, smoking comes up over and over again with eye health because smoking is pro-oxidative. So what they found is that if you smoked if you had alcohol, or you had lower amounts of vitamin C, serum vitamin C, you had an increased risk of cataracts. So conversely, if you had levels of 49 micromoles of ascorbic acid, so that's a blood test that you can do, it was associated with a 64% decreased risk of cataracts. So this is another thing that you can look into. So Ed was asking again about the cataracts. Here is where you would look on the DNA version. On the DNA part of the app. And then you can also look at the vitamin C sections of the app as well. Sunlight exposure to the eye. So this is a really interesting topic because we know that UV light, when it comes into the eyes and it hits the eyes, can cause damage within the eyes. So this is why, and then the other thing to keep in mind too, is that when the sun comes down and it hits buildings, it hits the sidewalk, or in some cases like the ocean or the snow, the light now also bounces back into our eyes. So we get significantly more inputs that happen. There is some concern that if you don't use sunglasses correctly, you could potentially overexpose your eyes to increase UV exposure, because what ends up happening is that when you wear sunglasses, your eyes are actually going to dilate a little bit. So constriction is they're really, really tight and small. So when you go outside, you want your pupils to constrict. And then when it's dark, they open up. And you can see a really great example of this with animals, especially with cats. During the day, they have little slivers of their pupils. And then at night, they're huge. And you can actually see the tympanium membrane reflecting when you look at them with a flashlight, because their pupils are so big that you can actually see this membrane is allowing the light to bounce back and forth. So depending on the quality and the type of sunglasses that you wear, your eyes are going to naturally dilate because it's a little bit darker. So you want to be mindful of the amount of UV rays that are coming in and what it could be doing with it. But again, we're going to be talking some more about light and just how to balance it, because it's a really important topic. So let's talk about homocysteine. Homocysteine is a blood test that you can test when you go to your practitioner. You can order it yourself through Ulta Labs, Direct Labs. But homocysteine is the byproduct of when you eat animal protein. Animal protein has methionine, and then the body is going to convert it into homocysteine. Totally normal, very natural. Homocysteine is inflammatory at higher levels. We expect homocysteine. Our body knows exactly what to do with it. It's just when our blood tests start to get over 10, 11, 12, and higher, now it's going to be potentially causing inflammation to our endothelial lining. And as we had talked about previously, we talked about homocysteine in the setting of our vasculature and the heart. Well, now we're talking about it in terms of the endothelial linings in your eyes. So again, it's the same thing, just a different part of the body. And so what ends up happening is that when you have elevated homocysteine, many, many different things can happen, including retinopathy, cataracts, retinal vessel atherosclerosis. So just like we can get atherosclerosis in our heart, it can also happen in our eyes as well. And the thought is because there's this vascular endothelial dysfunction that happens. And then remember that when you have the elevated homocysteine, you have increased cytotoxicity. So it's toxic to the cells. Elevated pro-inflammatory properties, which can cause more lens opacification. So you're making your lens more opaque. You want them to be clear, as well as optic nerve damage. So elevated homocysteine levels can also cause neuropathies and nerve damage. So the same thing can happen in our eyes. Now, here is the kicker, though. If you have enough vitamin B12 and methylfolate, your body should be able to convert the homocysteine back into methionine. So if you have elevated homocysteine levels, taking a high quality B vitamin, making sure that you have your methylfolate along with a methyl or an adenosyl cobalamin, that's a form of B12, that's going to help lower your homocysteine levels. However, here comes the asterisk. In order for you to absorb B vitamins, you need to have an acidic environment in your stomach. You need to have a low stomach pH. So if you are taking a proton pump inhibitor, if you are taking an H2 block, if you're taking anything for GERD or for acid reflux, chances are it's going to be harder for you to absorb your B vitamins. And so you may not be able to get your homocysteine levels down. If you don't take any of those and you are getting older, you may need to think about some digestive enzymes, some pepsin, some ox bile, or maybe some betaine HCl to help your stomach produce enough of those gastric juices and a lower pH as well, so you can absorb those B vitamins. Because as we get older, our ability to absorb our B vitamins do naturally go down. And I also forgot to mention on B6, pyridoxine or pyridoxal 5-phosphate is also a very important cofactor in this picture as well. And I just wanted to highlight here all of the different things that can happen with elevated homocysteine levels. And just today, right before this presentation, I got a fabulous email from Dr. Jeff Bland, who's considered the father of functional medicine. And there are a couple things I just wanted to share with you that were really, really interesting. He said the eye is one of the most oxidatively stressed parts of the body, and our retina is our most metabolically active tissue. So I think we often think about the most metabolically active tissues or parts of our body as our heart because it's doing so much, but it turns out it's our retina. The retina has a constantly high need for oxygen and energy, yet depends on minuscule, delicate blood vessels to deliver nourishment. The eyes receive light and translate it into nerve impulses, and all of its specialized structures are highly susceptible to damage from light exposure. Eyes' nutritional and energetic demands also cause them to be hypersensitive to elevated blood pressure, elevated glucose levels, and increased ocular pressure. So that's the glaucoma, each of which may strongly relate to lifestyle inputs. So this is where I was talking about that what we are get diagnosed with or what we might be experiencing in life, we don't realize it, but it is directly affecting our eyes and our eyesight. And because we've got such tiny, tiny little blood vessels in there, it's much easier for us to affect it faster, and we don't necessarily realize it, and we just simply attribute it to aging. So again, just another visual so you can see what happens with the elevated homocysteine levels and what it does in our body as well. You can take a look at your app and see where you are with B vitamin deficiency in correlation with the eye health. So again, this is going to be specifically, these genes are looking at folate, they're looking at B6, they're looking at B12. And so this is what I was talking about earlier about helping you keep your homocysteine levels under control. Glaucoma. So we touched upon this a little bit earlier, but glaucoma is the leading cause of irreversible blindness. It affects 60 million people worldwide, and by the year 2040, it is thought to be going to expect 110 million people worldwide. Now, here's what is very interesting. Glaucoma development varies very, very vastly all over the world, all over the different countries. In Africa, they find it to be as high as soon as you turn 40, they see a lot more glaucoma. And it's very low with Eskimos in Alaska. Now, you might say, well, why is that? And that seems really interesting. Well, in Africa, there's a lot of discussion that there isn't enough nutrition that is provided for individuals when they're growing up. Also, they are right on the equator, so the UV exposure is much, much more pronounced. Now, the Eskimos, too, are going to have quite a bit of UV exposure. The Eskimos do tend to have a higher fat, higher protein diet, and they don't eat as much in terms of grains or vegetables. Now, of course, that has changed with the introduction of processed foods. So their availability is very similar to that of other parts of the country. But they do tend to eat a lot more meat, which can be incredibly helpful for the amino acids for helping to protect our bodies as well. So one of the other parts of this is diabetes. So if you have rising blood sugar levels, you may have an increased risk for glaucoma. So as that blood sugar goes up, as that A1C goes up, your risk of glaucoma does go up. And so it's really important that when your practitioner talks to you and says, we need to get your blood sugar down, it's not just for diabetes, it's also for your eye health. Because what ends up happening is that we get something called age-related glycation. And so essentially the sugar molecules attached attach to our red blood cells, and those go around and attach to different organs. And this is how we start to have kidney damage. This is also how we lose our eyesight and have glaucoma develop, is because we're getting more sugar molecules into our eyes, into our kidneys. That's going to be prone to oxidation. You don't have the necessary nutrients or the antioxidants to help protect it. And then the eyesight will start to wane. And there is a strong genetic component around glaucoma. So take a look at your app so you can see where you are on that. And if you are at an increased risk, definitely do monitor your intraocular pressures, as well as your glucose and your insulin levels as well. Mariah was wondering, does prevention actually help for macular degeneration? And the answer is yes, it does. Because macular degeneration is really, really but it originates from a place of nutrient deficiency. So making sure you're getting your carotenoids, making sure that you are having higher levels of antioxidants, zinc, vitamin C, vitamin A. All of those can be really, really important. And as a matter of fact, there's a study that was done called the Age-Related Eye Disease Study. And what they found was that they took people at a high risk of developing AMD, age-related macular degeneration, and they lowered it by 25% when they gave them a combination of vitamin C, vitamin E, beta-carotene, and zinc. So yes, absolutely, prevention does help, and it makes a big difference. And the earlier you can start, the better off you are, because of that whole thing around tissue sufficiency. Our tissues need enough nutrients to be able to do their job. And if we don't provide adequate nutrition, or our lifestyle is depleting it much, much faster, so think alcohol, smoking, or an ultra-processed diet, now we don't have those nutrients to be used in other parts of our body. And so this is the study. These are the dosages that they looked at. You can see vitamin C, 500 milligrams, vitamin E. They used the alpha tocopherol version. I really encourage people to look at more of the delta and the gamma. That appears to be more protective, especially for the heart as well. Really high levels of zinc, 69 milligrams of zinc. I usually encourage people to stick to about 50 milligrams. I like a zinc monomethionine or a zinc citrate as an option. Copper, you do want to be careful with as you get older. When you take a lot of zinc, you will deplete copper, especially in this level. But if you keep your zinc dosage about 50 milligrams or below, you don't need to necessarily worry about copper depletion. You can always check a ceruloplasmin or a copper blood test to see how you're doing on that. But yeah, do be mindful of the interaction between zinc and copper. And if you're older or you're at a cancer risk or you have cancer, you may not want to take copper as well. Vitamin A is a really important feature for eyesight. We talk about it with night blindness. But if you happen to have this gene where you can't convert beta carotene into the retinol form, you are not going to get the benefits of eating those carotenoid-rich foods. And you're going to actually want to take a vitamin A supplement to make sure you're getting the active retinol form. So we talked a lot about the UV rays and the eye and what happens with the eyes and how do we balance this? Well, the other part of this is what type of light wavelength is coming into our eyes is actually going to affect the mitochondria in our eyes. That's the powerhouse. That's of all of our cells. That's where ATP is made. And it turns out that the neurons of the central nervous system are absolutely dependent on the ATP that comes from the mitochondria. And so what they're finding is that shortwave or blue light. So again, think cell phones, computers. Yes, I'm on one right now. It is going to affect flavin, FAD, which comes from riboflavin is one of the cofactors on that, and also for cytochrome constituents. So those are your cytochrome P450s from the liver enzyme, are going to be associated with how much reactive oxygen species you have, the type of cell death you have, and what could be happening in your eyes. So the type of light that comes in actually really does matter quite a bit. And this is an example of the different wavelengths and what our bodies and our brains would naturally be expecting. We do expect blue light in the morning, first thing in the morning, and then in the evening, it's going to give way to more of that red and the orange. Unfortunately, what we usually do We may be outside towards the end of the day or going for a walk, and then we come in, we turn on all of our lights, we get on our phone and our computers, or we start watching something. Do not underestimate the amount of blue light that comes through your TV. It's pretty impressive. So what ends up happening is that the photoreceptors that we have in our retina, and again, remember, they're very sensitive to oxidation, to reactive oxygen species, et cetera. So we want to be very mindful of what's coming in. And at night, with the orange and the red light, our eyes should be dilating and should be opening up to help us see in the dark. But when we are in front of the TV, or we turn on all of our pupils are actually going to constrict significantly. And so what ends up happening is that, and we've talked about this before, it's just blue light really does throw our circadian rhythm off, but it's also affecting our eyes significantly. And I wanted to show you some examples of individuals from their epigenetic results, and you can see across the board, most people's eyesight is aging much, much faster. And all of these individuals mentioned that they do use their computers and their tablets at night. So I thought this was a really great way to remind all of you, so you could actually see, and this is prior to them necessarily experiencing any specific eyesight changes. This is just what's happening on the level of the DNA because of the lifestyle that they're living. So you can see some people are really aging much, much faster, and then other people are normal. So it's just an important reminder. So, and again, the effects of smartphone with or without the blue light, and what you can, and what it does. It is actually going to make a big difference. It delays melatonin. It increases body temperature, by the way. Your body likes it nice and cool when it's time to sleep. And so when that body temperature it gets elevated, you are not going to necessarily sleep as well, which is going to make it harder for you to fall asleep. It's going to make it harder for you to get off of your phone. And so you don't necessarily pay attention to that. Now, I want to quickly touch upon, because I'll be mindful of our time as well. When actually, we have a question on it. Never mind. I'm going to skip ahead, and then I'm going to talk about it in a second. There are many different things that you can do to reduce the digital eye strain and the blue light. You can get blue light blocking glasses, which I should have been wearing today. The other thing that a recent study found late last year was that when you wear blue light blocking glasses, your ability to stay focused and actually sustain the amount of time that you work was much longer than if you didn't wear the glasses, because your eyes started to hurt and they started to fatigue. So then you would look away or get distracted and do something else. Ironically, when most of us get distracted or we want to break from our computers, what do? We actually pick up our phones. So really important to make sure that we are taking time to look away from the computer, making sure that we're looking farther away, because computers are much closer. Same thing with our phones. So being aware of all of those. And I've got several questions I'm going to get into. So really quickly, in terms of takeaways. So know your risk factors. Because again, if you're at a higher risk for glaucoma, so much more important for you to monitor your blood sugar levels. Leverage nutrient-dense foods to protect your eyes. Don't underestimate what you're eating isn't going to have an effect. It really is. Your B vitamins, vitamin C, antioxidants, and xanthine. So I'm going to touch upon xanthine really quickly. It is a xanthophil. It's an oxygenated non-vitamin A carotenoid. It's made by microalgae and phytoplankton. And here's what it does. It is eaten by shrimp and crayfish and lobster, and that's how you get that really lovely orange or kind of pinkish hue. But because of the type of carotenoid it is, it can absorb and neutralize reactive oxygen species originating either inside or outside the cell, which is an extraordinarily protective capacity, and it's rare among antioxidants. So xanthine is a great thing for you to take to help protect your eyes. Be aware of the type of light that enters your eyes. What time of day is it? And what type of light should be entering your eyes? Be sure you monitor lab tests for other conditions, because that may be giving you a precursor or an insight into what's going on with your eyes. And I ran out of time, but there's also some new research which suggests that the microbiome can also sense light. So in the darkness of our stomach, there is some light sensing going on there as well. All right, I need to get to questions here. So Anna wanted to ask about what to do to reduce blue light exposure. So of course, limiting your screen time, being aware of how much you're on it. The new phones, by the way, have some fabulous digital well-being blockers that you can put on. You can put time limits on your apps. You can do f.lux. You can make sure that your room is completely dark. Don't turn the TV on before you go to bed. Use your blue light blocking glasses. Put your blue light blockers onto your phones, and really make an effort to also read and get off of your phone at night. Scott says he can't go out first thing in the morning without sunglasses. And why is that? Well, Scott, this might be a symptom of adrenal fatigue for you. So as I was talking about, our pupils dilate when it's dark, they contract in the morning, and they get really constricted. Well, it turns out that when our adrenals are fatigued, or we're really feeling exhausted, our pupils can't constrict in the morning. And so they will actually stay more dilated. When they're more dilated, the more light can come into our eyes, and it hurts. So there's some functional medicine practitioners out there who will actually check, and they'll just hold a small flashlight to the side of your eyes, and you can see how the pupil is contracting or dilating. And you can see it will, if you have adrenal fatigue, it tends to do this. It's sluggish. It doesn't respond right away. It should respond incredibly quickly. So that's why. So Scott, definitely look into supporting your adrenals, some vitamin C, perhaps some ashwagandha. And as you get more sleep, as you're getting higher quality sleep, and your adrenals are feeling more nourished, you should be able to go outside without the sunglasses. And in the morning, you don't want to go out with sunglasses, because you want that light to be coming in, because your body expects it. If you're going to be outside for longer periods of time, longer than 30 minutes or so, then yes, do put on sunglasses, because we do want to protect our eyes as well, and just be mindful of that. And then also be aware that even on cloudy days, that can sometimes be even trickier, because it's cloudier, our eyes might dilate a little bit more, letting more UV light in. Melinda said that she has PCOS and has been told there's a link to her chronic dry eyes, and also she's being monitored for glaucoma. So, and is there a genetic link to that? So, Melinda, hopefully we covered the genetics on the glaucoma. PCOS is an imbalance of your reproductive hormones, especially around estrogen and testosterone, as well as insulin. Insulin resistance is a big player in PCOS, so you tend to have elevated glucose levels. Those two together are going to potentially pave the way to the glaucoma that we talked about. What they have found with the dry eyes and with PCOS is that it appears to be associated with changes in your testosterone and your estradiol levels. So I would definitely take a look at your hormone levels to get your hormone levels balanced. Maybe you want to think about a Dutch test, which is a urine test, to take a look at how you're metabolizing your hormones as well. If you need further help with that, send us an email at info@mytoolboxgenomics.com. And with that, yes, okay, I made it. So next time, we're going to start with how to get started with epigenetic and DNA tests. We've given you lots and lots of information, but I have gotten several questions of how do I get started? So I'm going to take you through some family members' reports and just show you this is what's going on. This is how you start. This is where you focus. This is how you approach it, because I recognize that this can get really, really overwhelming. There's just a lot of information for you to keep track of. So really excited for that. And then 2 weeks after that, we're going to be talking about families and how to bring this information to families, how to get families on board. Also, especially if you have tweens or teens, because that can be a very difficult journey to work with as well. I also wanted to share that I am currently I have 5 spots open. I'm working with motivated mothers to help them optimize and streamline their family's health so that their own health and emotional well-being does not come last. So if this is you, feel free to book a complimentary call with me where I will remove the confusion around your health questions, provide simple, effective health strategies and resources so you can remove those nagging confusion questions and focus on yourself for once. I know mothers need all the help they can out there, and so would love to have a conversation with you. So if that's something that interests you, again, send us an email, info@mytoolboxgenomics, and we'll get you set up for that. So everyone, it's been a pleasure. Thank you so much for your attention. From My Toolbox Genomics, Toolbox Genomics, I'm Dr. Erika Gray. It was wonderful to see all of you, and I can't wait to see you here in 2 weeks to review how to get started. Thank you so much.